Okay, I'm going to show you both on two different problems. Okay?
Yeah.
So, big picture. Here we have Euler. Yes, it was 1700s. I think that's 18th century. Um, his book Institutium Calculi Integralis, published in 1868.
So yeah.
And you probably definitely want to read that in Latin, don't you? Yes. So, a common question in the real world with approximation is how close is close enough? More accuracy typically requires more time and money, both of which are limited resources. You need to balance the need for accuracy and the limitation of these resources. Now, I would say the level of accuracy might depend on how many more resources it is. If you've spent 6 months devising this and planning this out, and you're going to build a $10 billion machine, you probably want a lot of accuracy. You're willing to spend a few extra days of work to get more accuracy, correct? And honestly, at this point, if you set up the programming correctly, you're not writing this out. You don't have to type it into a calculator one shot at a time. Double check all your work. You need to double check your work on your program and let it do the calculations for you. Okay? So, numerical solutions using Euler's method. Hey, it worked. The internet's still probably not where it's supposed to be, but we're going to use this one with a step size of 1. And this is my differential equation. Here, a lot of times they're instead of dy dx, they're going to write y prime. Okay? This is not separable. I can move dx to the other side, but I can't move the y away from it because it's a plus minus. I cannot divide by something to move the y. I I have to get the y to the other side, and I'm going to have something go with it. Any way I do it. Okay.
Wait,
When
what?
I divide, it might be able to take and leave the stuff on the other side, but it's going to end up multiplied by dx. Or I bring it over, and when I move dx to the other side, I'm multiplying y squared by dx.
Why can't you just add the y for the other side?
Okay, I can't. So I add y to both sides, right?
Um, then
Now I have, when I multiply, I have to take dx times all of them, and I end up with y squared dx plus dy equals x dx. And if I try to divide this by dx, I got to divide. If I try to divide that, I got to divide that. And I just end up back where I started. I end up in a loop. Okay. So this is not separable. So you can't get an exact solution by separating. So, doesn't work. So now it asks us to use Euler's method to estimate y of 2 with a step size of 1. So Euler's method uses this. You can use delta x, t. Revision Village uses h, which for step size, whether it's an h might be good because sometimes we're going to use x's, sometimes we're going to use t's, change in t. So y So this is like writing a sequence, a recursive formula. So what I'm doing is x, there is no change in x formula. There's no dx d something. I don't have an x prime, which means x prime is 1. I don't have an equation for x prime. Xn is the previous x. Okay. Xn plus 1 means the one I'm on. So when I go to get the next one, I'm using the current x plus the chain. Okay. So I'll put this in table form. 0, 1. It only takes, this is h. To get from, with a step size of 1, my starting value is here. And I need to get to x equals 2. My step size is 1. To get y prime, I do x1 minus 1.5 squared, and that's negative 1.25. To get this y here, I take my formula. Y sub n means the y above it. 1.5 plus h is 1. Y sub n prime would be the y prime from the line above it. 1.25, negative 1.25. And that is positive 0.25. This ends up being a very terrible approximation. You never want to use step size of 1, or probably never, unless you're trying to go to y 500 million. So, does this make sense so far?
You tell me how you got for the 0.25 here.
So, using this equation, y for this one equals yn would be the one y before it, 1.5. H is 1, that's my step size.
Okay.
That's h. And then yn prime is this guy.
Okay. Okay.
And then I put in the equation, I get 0.25.
Yeah.
My approximate here is 0.25. Okay, the general formula for if it's a single, it looks like this. If it's a coupled where you have, so a coupled differential equation is going to look like this. You're going to have two of them. And that is going to look like this. Those are your general formulas. Like, basically what I'm telling you is memorize them.
Will they be in folder packet or something?
I don't think so. So if we don't have if it's dy dx case, you could say xn prime here, but x prime equals 1. So I don't really need it. Okay. It's the same formula, but x prime equals 1. So we just kind of get rid of it. Does that make sense? Do you guys have this? I'll leave the red part there for a little bit. Because what we're going to do is the same example, but now we're going to do 10 of them. Don't worry, I'm not going to calculate all 10 of them. I can show you the calculator method. I'm going to do part of it by hand. I can show you that if you look at the answer keys, they do 500 by hand. You don't actually ever do that. Like they'll give some realistic examples and then they show you 500 by hand. They'll never ask you to do more than 10. Okay. 10 is still a lot. They might ask you to do 40 and you could use a calculator. I don't think they'll ever ask you to do more than 40. It'd take forever to scroll down the calculator to do 500. I have no idea. I've never taken it. It also depends on who you have as a professor, what level of crazy they are. Like you have some experience with professors now, and you'll see some of them are really, really intense, really crazy. This is how we had to do it in 1960, and we didn't even get a calculator. We had to use our slide rule. Um, uh-huh. And some of them are like, I'm paying for this class. So, yeah, I have no idea. You guys are going to end up all over the place, probably at different colleges, and have all over the place professors. Different professors at different colleges require very different things. Okay, so now we're going to try one and we're going to work out what it would look like with 10. So that's going by tenths, step size of 1/10, which is not that small, is it? But we're going to, no, we did one that was in tenths. You could, so here's the same thing, but now we're changing our step size to tenths. And I'll show you method 1 on the calculator with this one. So, same equation. H. It's going to take 10 steps to get to 2, won't it? I'm going to stop. So I'm not going to show them all. 1, 1.1, 1.2, 1.3, 1.4, 1.5, dot, 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 2, right? Y starts at 1.5. Y prime. And we still have the same Y prime. Okay. That does not change, but this second Y here is going to be different. The Y for 1.1 gives me Y of 1 which was 1.5, minus, essentially I'm doing the step size times that slope. Does that make sense?
Wait, H is the step size, right?
Yes.
So why on our table is H going by one? 0, 1, 2, 3, 4, 5, 10.
Oh, that shouldn't be H. That should be called N. It's the counter in the sequence.
Okay, yeah, that's what I thought it was, but I just got a little bit.
Yeah, that I should have called that N. I'm still a little new at this. I understand what it's doing now, but I'm still a little new at it.
Mhm.
So I'd stick that into a calculator. And over on my other computer, I'm just going to look at what the calculator would give me because I have an answer key. So that's 1.375. Now, before I go to the next one, I've got to get y prime. Which I'm just using this formula. But now I'm using the 1.1. This doesn't have the previous ones. So I'm using 1.1 for x and 1.375 for y.
Why are we using 1.5 in the first one? Sorry, I'm just realizing this. That's X.
So looking at this formula,
Okay.
so this is saying the next one I'm using the row above it.
Sorry.
When I'm calculating y prime, I don't have any n's in it. I'm using the current row. Okay? That is a trick to this table. If you look at how many decimal places, you've got to carry a lot of decimal places when you're doing these approximations. Okay, which numbers am I using? Let's see if you guys can do this.
8.375
Hmm.
plus 0.1 times negative 0.79000625, that thing.
Hmm. And I do need you to do 2 or 3 of these by hand. Okay? So that you get what you're actually doing. And that equals 0.2959. Oh, it's plus a negative. I was like, why did I subtract? Because I remembered it was going to get less. It's plus, but then that's negative. I put the negative in twice. Why did we do that? Because I remembered what I did because I did the example before. Now, what's my next one here?
Two. One, two, three.
It's 2959.
Mhm.
Mm-hmm.
Isn't it current row? Wouldn't it be 1.3? To find the one from current row. No.
Oh,
One-
this is where I'm at, actually.
Wait, what?
My rows don't line up.
Oh, okay.
I was like, yeah, kind of looks like 1.3, but no, that's not where it's supposed to be. So that equals negative 0.4795. And then, keeps going. Um, your final answer here is 1.299 or 1.3. That's a whole lot different than 0.25, isn't it? When we did a step size of 1, we got 0.25. Okay, I'm going to show you a picture of what it's doing. The y prime is the slope. No, our goal is to get the value. So,
Wow.
to get the y value. So let's look at what it was. So we had this differential equation. And this was our initial point. We're trying to approximate that point using a slope. Okay. If we do a step size of 1, use, we're like, okay, we got a slope there, we go down to there. If we use a step size of 0.1, we end up somewhere like here, and now we're using a new slope. At each one of these points. Notice how the slopes are changing pretty drastically as I move away from 1, isn't it? Devin, Dylan, that makes sense? So, so I've got here, if I use a step size of 1, I use this slope and I just go for a whole 1. If I do a step size of 0.1, I use that slope to go to here. Then I use the slope here to go to here. Now I use the slope that's there to go to here, then here. And so these slopes are changing quite a lot in that interval. If you look at the slope field, right?
Looks like it's never gonna touch that Y1.
This one,
Yeah.
it's not if you approximate it by tenths.
Not me
We're trying to predict Y1.
Oh.
Okay? So if we use a massive, the slope from the first one, we end up quite a bit off. If I used hundredths, I'd get a lot better prediction, right?
Slow field.
Yeah, because the slope is adjusting all the way. Here, you're like, we were going down when the slope right here says I should be going that way. And I'm going down at a slope of -1 as opposed to a slope of +1 there. Because my approximation step size was so big. A tenth is actually pretty big. Okay, you ready for method 1 on the calculator? We'll see.
Negative 0.4795.
Yep. But if you really need the numbers, they're all in the book at example 2 and 5.16.1. 2.9999, yeah. I need to write down a few pieces of information before I go to the calculator. Actually, I can have them on my other screen. Tell me when you're ready for me to switch this. Okay. So Well, there's a differential equation. I'm going to do this in a document. I think I could actually get away with it in Scratchpad, but so I'm going to start with a calculator. And I'm going to call this YP for Y prime because I can't type in the dash. So YP, and I'm going to define the function of Y prime. So I was given this equation.
Wait, how'd you get that to, right?
Colon equals is control of, see the button that's red? The matrix button?
So.
See the button that's red up here.
Here.
On the button that's red on the screen right here. And so that's the defining a function thing. Oh, I need to call, oh, sorry. I missed something. So Y prime, I have to do this with function notation of x comma y. So that tells me that both of those are variables. And they recommend doing h and setting h here. So it's easy to change if you want to. Oh, this definitely has to be in a document because I'm going to add a spreadsheet. Everybody got that so far? H colon and equal 0.1. So this is my n column. I'll call it nn just for, and I'm going to do 10. Oops. So I'm going to start by entering both of these. I could literally just enter the x's, but I'm going to show you how to do this by formula. That makes sense? This is going to work just like a spreadsheet. Equals the x above it is column B1. That makes sense? Oh no, I should just do B1 plus H. And then I'm going to do menu, data, fill. And that will allow me, it'll take my formula and run with it to there. I was still clicked on the box I was at, and then I did menu, data, fill. I scrolled down. I just took the down arrow. I hit enter to end it.
Yeah, so don't,
So I'll do it again. Menu, data, fill. Now I'm just going to click the down arrows. And when I get to where I want, I hit enter. That makes sense so far? This one, um, maybe we'll have to pause and help you. C1 plus H times. Now this is where this is Y prime, right? YP, my function, B1 plus, might have just been easier to type it. Oh no, not plus. B1 comma. This is X comma Y. So it's effectively function notation. That makes sense? My X is the row above's X. My Y is the row above's Y. And that was what we got, right? If you click back in it, you will get the formula. You can see it down kind of at the bottom here.
Wait, why are we doing the C1 plus H? I thought the equation was just X Y squared. So wouldn't it just be YP?
YP needs to know what the X is and what the Y is.
Well, yeah, but then,
So YP is Y prime of what is my X? Box B1.
yeah, but,
That's where it's getting the value for X. And then box C1.
what about the C1 plus H multiplied?
See, so you Y is Y sub n plus 1 equals Yn plus H Yn prime. So C1 is Y sub n H.
No, that's for Y, not Y prime. No?
Yes, I'm in the Y column.
Oh, sorry.
You don't have to actually make a Y prime column here. Okay? That's what this little piece of notation that I'm circling in is my Y prime column for the one above it.
Um,
I suppose I could have put that in column D, but I don't really need to because I defined the function. Okay? Now I got to go back and fill. So that's again menu, data, fill. And then I'm just taking the down arrow on my calculator. See the part that's red.
because.
Now that's probably cross country. Am I going? Yes, but not during this class. I'm driving the bus and it was out of fuel. So they had to, I was supposed to pick it up before school, but it didn't have enough fuel and we weren't sure if I could get to class on time if I went to go fuel it up. So, yes, 10:45. So, there's my answer. Okay? We have to move on to coupled. It's like, yeah, Izzy, why don't you see if you can help her get it to work? And while I get to the next section. Probably easily. It lasts a long time.
6 and 10 miles.
per gallon. Yeah.
What was that mean? Or, here, what was this? It was 36. 36 divided, just say the high estimates. Yeah, what is this? Six. 13.6
So,
dollars per. Not that's all.
so this is my coupled formula from before. I'm gonna have it on the side.
Is this another way to do it?
Well, now I've got a different set. I've got a coupled differential equation. So this is just the more general version, where x prime of n isn't 1. This time it's y. Okay? So I've got my step size here, h equals 0.25. So my n, that means to get to, I'm looking at x0 and y0. I'm going to put a t column here just to help you guys. X0 is 0 then, right? That means that time is 0. And they want us to get to 1. Oops, I mislabeled this. X and Y start at 1. So X prime is simply equal to Y. That makes sense so far? Y prime, on the other hand, negative X, that's 1, plus 1 minus 1 squared times 1. 1 minus 1 squared is 0. 0 times 1 is 0. So that's just negative 1. So now we're going to look at this line. And I've got to use these formulas. X sub n. So this is x for term 1. That makes sense? So for n is 1. I got to look at the x above it. 1 plus h is 0.25. X sub n is 1. 1.25. Y sub 1, the 1 above it, plus 0.25. Oops, I forgot the times. Times negative 1. Okay, x prime is simply y. Y prime at 1 is its x, negative x actually, plus 1 minus 1.25 squared times y is 0.75. And it doesn't have that in they didn't lay out the table the same, of course. And I get negative 1.6718 We'll round there. There's been way too many of those in life here lately.
What?
6 sevens. I just typed one on accident. You guys didn't even catch it when I was putting things in the calculator. I missed an enter between the 6 and the 7 putting in my list. Okay,
You don't want my game today.
so now I'm on x2, right? 1.25 plus 0.25 times x prime is 0.75. 1.4375. Yes,
So horribly tedious, yeah.
it is tedious. It's not actually that hard, though.
No,
You're not gonna do, I want you to do ones that are like 4 steps to do it by hand. Okay. If it's 10, 20, 40, you're gonna use a calculator. Okay. And I'll show you how to set this all up too. So the next one we got to calculate y. The y above it plus 0.25 times the y prime. Actually, that was a 1.9. Now, these are my ordered pairs, the x's and the y's, right? If I'm graphing it. If I just keep going, I'm going to skip over a couple. You get 1.492, negative 0.458. Okay. Does that make sense? If it's 4 or less in the questions, I want you to do it by hand. Because I need you to do a few of these so you really understand what is being done. That which will help you be able to program it. I believe example 2 just has us do the same thing, but now they want us to go to t equals 10. Okay, so we're going to do the calculator. Okay? We are not doing this by hand. Let's do it the method we just did, except now we've got to define 2 functions. And I'm just going to start a brand new document. And add a calculator. And I'm going to go start with XP. X prime. Cool. Nope. Oh, before I do the colon. I just need Y here. Because there isn't an X in this equation. But yes, it would be XY. You can enter XY, but you don't really have to.
It's why if.
You'd have to enter X, but then it's not actually used in the equation. So it's just more work than you need. Of this one is x comma y. And that is negative x plus parentheses 1 minus x squared times y. Make sure to hit the times y. And then let's define h to be 0.25 again. You know when everybody's there. I'm not going to put the t column in here. Hmm. Equal. So I can type as fast. No, I can't. Not to 40. Equals.
Wait, 40?
Yeah, we got to get to t equals 10. Going by. You can do fill, but you got to set up a formula there first.
Oh, and now everything's 13.
And I have to go down to. I guess this isn't n, this is t.
14.
Oh, no, I screwed up. It has to start at. Okay. Equals this plus h. I needed to just do a formula from the beginning. I went by 1 instead of.
Oh, we gotta go.
Yes.
There were just delete the entire array. Anyone perfect.
A1 plus h. And I have to go to 41. That's where it became important that I put this column in. And then I filled until I ended up having to go to 41. Yes. Did you define h?
Ooh,
Yeah.
Did you have equals in front of it?
well,
Has to be having equals. Okay. X. My x is, remember the formula? Let's do a different color that's a little darker. Plus h x prime. We defined x prime. That's what xp was, right? So equals. Always have to start with equals. X is the one above it, right? Plus h times xp of xp was of y, correct? So that's C1.
XP.
xp was of y. That's down here. Okay, everybody got 1.25.
Now,
Do you see the formula in the bottom?
no, yeah, I do, and then I try to data fill.
Okay, so if you got that formula right, let's check data fill.
There aren't Ys.
Yeah, it's not gonna fill yet because you don't have the Y's. So menu, we can fill. It's not gonna do, it's going to have problems any way you do this.
Yeah, that's what.
Yeah, that's because it hasn't calculated the Y's yet. We gotta put the Y formulas in it. It'll fill both of them at the same time. And Y is equals Y plus, I have to click back in it, plus H times YP of B1 is the X, comma C1 is the Y. Notice it just filled the next box for me. Because now that I calculated the Y, it filled. Now that I calculated the Y, it had the Y it needed to calculate that. So I'm doing Y prime of the X and the Y before it. Do you understand what I'm doing here with the functions? That this is the Y prime using the X and the Y from the row above. This is the Y from the row above. Now when I go fill, it'll fill everything out for me. Menu, data, fill. Okay, that didn't go. Didn't work, so I'm just going to do it again. Look at my coordinates. My answer is these coordinates. And I gave my answer to 3 sig figs. We keep a lot more in the calculations. The calculator keeps a lot more. Does that make sense how to do that? Now it's time to learn how to do it by the other method that's going to produce a graph. And the other method, well, we'll show you. I can show it with the next example. Actually, the next example is cool, but they don't really give enough to actually do it. Oh, yeah, they do, but we'll do it with this example to keep it easier. Okay. And I have to get going or we're not gonna have time to get through this. So we're gonna do a new one. And go to a graph. So go to a graph. I have my equation. I'm going to show you how to translate this into sequences. Okay. So, because we essentially have a sequence here, right? So I'm going to call a sequence, and I'm going to define this using, I need to go menu, graph entry edit, sequence, and we're just going to go sequence. Okay? And I'm going to change this to u sub n plus 1 so it matches my thing. Okay? X sub n is u1, because look at my sequence as u1 of n, is or n plus 1, right? So it's going to be u1 of n. It'll get bold once the sequence is fully defined. Okay? Plus h was 0.25. Graph entry edit sequence. 0.25 was the step. Yep. That's my h. xn is y. Y is going to end up being u2. Yes. Good band. And I'm going 0 to 40. That's how many steps I had, right? Remember my n column that I was dealing with? I'll come back in a second. I'm going to turn off the graph on this. Initial term was 1. That was your x0. Remember we had x0 equals 1. That's what goes here. We also have y0 equals 1. That's going to come up in our next one. And I unchecked this box. Okay? That's going to be helpful later so it doesn't, my graph is less confusing. yn plus h, y prime of n. Y prime is going to be a little ugly. 0.25. Y prime, I'm going to need parentheses to have this whole x thing, right? So I'll clean up a little bit. Now I'm going to scroll down to U2. And I need to change it again to n plus 1. Yn is U2 of n. All these x's are U1. You'll see that now that U1 is bold because it was fully defined. Plus, there's going to be a lot of stacked parentheses here. 1 minus U1 n squared, because that's, so any place where there's an x is a U1 of n. Times y. Y is U2 of n. Mm-hmm. And go up there. I changed my initial terms in my step the same as I did the last one. Be careful with initial terms that it's the same as what it actually is for that. These ones happen to be the same for x0 and y0. They won't always. Okay? Now I'm gonna hit enter. It makes this nice sequence. Um, the first one, it didn't make a sequence because it didn't have all the U2s. Yes, I'm going to in a second. So once I hit enter, I can turn uncheck this box.
Mine made it up, so they don't look like this, so it's like a little like really careful.
Then you have something wrong.
Is this right?
Yeah, now you need to uncheck both boxes. So hit tab again and uncheck the box so it doesn't display. Okay, I'm gonna hit the last thing because we're basically out of time. But I can get the last thing and I will get this video up if you miss it. If you need to double check. So menu, now we're gonna go graph entry edit sequence and we're gonna go custom. U1 of n is my x. U2 of n is my y. And I'm going again 0 to 40. And if I do trace, menu trace, I could get the 40th. Notice the ends counting here at the bottom. It's tracing how this thing is going around the graph. Okay.
Oh,
Yes, U1, U2. And then I set the boundaries to be the same. And if I graph trace, it will get me the same answer, I think. If I didn't make a mistake, which I don't think I did. Yeah, I get the same answer. You'll want to be able to see that graph for things we're going to do in the future.